So there are definitely theorists. All right, now it's recording. Sorry about that, students who are watching this later. You missed about 15 minutes of content before we got to this portion of dreams. So there are theorists who look only at the cognitive theory of dreaming and thinks that is the only method by which we dream. And there are definitely researchers who also think that it is only the activation synthesis, but most researchers who are looking into dreaming, think that it's some combination of both. And that does make sense to me just in what I know about neurology. But again, that's not my expertise. So good reason for some of these experts to think that it could only be activation synthesis or could only be the cognitive theory of dreaming. And Brianna says that happens to me all the time. So the sounds, maybe the alarm specifically, being inserted into your dream. Yeah, can make it really hard to wake up when it just becomes part of a dream. So, all right, any other questions about dreams and dreaming? We talked about sleep. I thought I had a couple other slides about dreams, but maybe that's in my developmental class. All right, well, let's move on to how drugs can affect our consciousness. So psychoactive drugs are essentially just drugs that alter the nervous system and can, in some cases, affect and alter consciousness. So many psychoactive drugs, not all of them, lead to tolerance, and tolerance is defined as essentially becoming more tolerant to that drug and then needing to use more and more to get that same effect. So many psychoactive drugs can also lead to physical dependence, which means essentially that you are physically dependent on that substance to continue your day-to-day functions. You end up needing that substance to function without having withdrawal symptoms. So as an example, coffee is one of those psychoactive drugs that can cause a physical dependence. Of course, I would never become addicted to coffee and never have had headaches when I don't get enough coffee in the day. No, that happens way more often than I should probably admit on a recorded lecture that's going to be on the internet. But no, that's one example. So a lot of these psychoactive drugs can cause a physical dependence so that your brain and body don't work at the level you need them to do your day-to-day activities without having withdrawal symptoms. So to stave off those headaches, those caffeine withdrawal headaches, I have to drink that certain level of caffeine. So I could like wean myself off of it. But if I jump to no caffeine, say tomorrow, I would probably end up having a headache for that day unless I drank some caffeine. Or, yeah, that's how I get my caffeine anyway. So most drugs are using very similar pathways. Like we'll talk about in a little bit of specificity what kind of neurotransmitters a couple different drugs affect, but most of them actually use the very similar pathway as other rewards are processed by our brain. So whether it's seeing a bunch of puppies and having them jump all over you, or using a drug, or scoring a winning goal. A lot of these things use the same kind of reward pathway in our brain. And so this is part of that pathway. And we mentioned in our section on neurology and the brain's the structures and functions in the brain, that there are more than one reward pathway and reward center of the brain, but many of them use this specific, many things that make us happy or help us feel pleasure use this system. So just that it's using this system does not mean the drug is different or unusual in any way. So like I mentioned, seeing a bunch of puppies or scoring a winning goal also uses this same system, so this reward pathway. So using the ventral trigeminal area, the nucleus accumbens, and the prefrontal cortex. So different drugs affect different parts of these in different ways. So it might, well, we'll get into more specificity when we're talking about the individual ones. So let's start with depressants. We will, hopefully this website is working today. I didn't double check. I double checked last time, but not today, to make sure this was working. So this is a cool little thing from the University of Utah. It's called Mouse Party. It's a little flash game. Oh no, do I not? I wonder if my other browser has a Flash plugin already. Give me just a minute. Because I thought it was on this computer that I was using it. I could just download it as well really quick. All right, I'm reinstalling Flash Player. Let's see if I can get this to work.
I'm getting something.
Oh yes, Flash Player won't be working after this or next month. So I'll definitely need to do something about that. All right, so it's working. Then I'll have to figure out something for next semester. The drugs and consciousness, yep, I can definitely do that. So this is actually just a picture from in your textbook, figure 10 in the chapter. So you probably need, or we're needing this one for your notes. All right, so let's get a little more detail on what happens in the brain for a couple different drugs. So we'll start with depressants. I'll let you hear the funny music here. So essentially what you do here is you are the lab technician and you've drugged up all these mice. So you have a mouse here who is on heroin, one who is on ecstasy, using marijuana, methamphetamines, alcohol, cocaine, and LSD. So you can put them into your centrifuge, see what's happening at the neural level, and this Mouse Party Flash game will give you a lot more information than you necessarily need at your level to understand what these drugs are doing. But if you are interested in any of these given drugs and how they affect your brain, it's a good place to start to find more information about what it's doing at the neural level. So we're going to be starting with depressants. So let's put a mouse who's using alcohol into the centrifuge.
Inhibitory neurotransmitters called GABA are active throughout the brain. These neurotransmitters act to control neural activity along many brain pathways. When GABA binds to its receptor, the cell is less likely to fire. Meanwhile, in another area of the brain, another neurotransmitter called glutamate acts as the brain's general-purpose excitatory transmitter. When alcohol enters the brain, it delivers a double sedative punch. First, it interacts with GABA receptors to make them even more inhibitory.
So those GABA receptors are now very much less likely to fire, is essentially what that's saying. So the alcohol causes that. So the GABA receptors, when it gets GABA into them, when the neurotransmitter leaves from this cell and comes in contact with this new cell, so this is a dendrite or a cell body of that cell, this cell is much less likely to send a signal down its axon.
Second, it binds to glutamate receptors, preventing the glutamate from exciting the cell.
So doing that, I mean, it kind of just said it all in pretty understandable language. So the are blocked essentially. So it makes it really hard for the following cell when it's receiving a message to then send that message on. So that is one reason it's considered a depressant, because it slows down those neural processes. So the glutamate receptors, they're not able to be affected by the glutamate neurotransmitter. The GABA receptors are not able to be as easily excited by the GABA neurotransmitter. So this makes it really difficult for cell 1 to then talk to cell 2. Cell 2 is very less likely to send the message down to cell 3, and so on and so forth.
Alcohol particularly affects areas of the brain involved in memory formation, decision-making, and impulse control.
So with that, that leads to things like harder time doing goal-directed behavior when using alcohol, because a lot of these neurons in these parts of the brain are slower to respond. So if you're trying to, say, drive or control certain impulses, it might be more difficult to do that because you might be sending a message and then the next cell is not now sending that message again. Right? And same with memories. It might be really difficult, especially if you're using a lot of alcohol, to remember what happened if you were using a lot of alcohol, because it's difficult for those neurotransmitters. Well, it's difficult for the cells to continue sending the messages, which makes it difficult to record those memories, and be as conscious of the experience. So that is how it's affecting the brain at that neural level. And it's related to the behavioral things we see from people using alcohol, as well as what you experience when you're using alcohol. So like I mentioned earlier, that goes into a lot more detail than you need to know. Well, let's just close it. We might do another mouse in a little bit. So that, again, goes into more detail than you need to know about the neural level of what's happening with alcohol. But it's a good tool to like get you started to understand the different classifications of the drugs and what neurotransmitters they could be affecting. All right, so depressants are a class of drugs that slow down mental activity. So with that, can small consumption of alcohol be healthy? So it seems there's varying research on this. So you'll find a report in a medical journal that says a little bit of alcohol with, say, dinner is good for X, Y, and Z health benefits. So like lowered blood pressure or things like that. But then you'll find other studies that say the opposite. So essentially what I take from that, seeing so many differing things, is that it might have a little bit of positive health effects, but it's not super clear enough to say that alcohol is healthy. And it's also harder because they are not usually doing randomized control testing of that. They're just asking people about their consumption of alcohol. So if I don't think this would be an ethical study, it might be, because alcohol is a legal drug for people of legal age. So you might be able to do this, is say, okay, so for the control group, no alcohol at all, eat food, and we'll do these cognitive assessments, these health assessments over time. And then for this group, we'll provide you red wine, and you drink 8 or 12 ounces, however much you decide as the researcher, once a day. And then we'll give another group, so you get 4 ounces of tequila every day. You could even do different groups that are doing different times. So that would be a way that you could get good causal data. I think because it's correlational, like people reporting, oh yeah, I have a red wine at dinner, about 1 drink's worth at dinner 3 times a week. So a lot of these pieces of research are correlational, which shows that there might be a relationship, right? It suggests there might be something there, some relationship between these health benefits and the alcohol. But because it's not a randomized control trial, it's really hard to say that, yes, the alcohol is causing these actual benefits, when it could be other aspects of their diet, people who are tending to drink the red wine with dinner versus people that are drinking something else with dinner. So can a small amount be healthy? It depends on the study you look at. For neural activity, it's always going to have the same effect at the neural level. So obviously more alcohol will make that effect more pronounced. A little bit of alcohol will make that effect less pronounced, but you're always going to have both those GABA receptors depressed so that they're not as likely to fire, as well as inhibiting what was the other one? The other neurotransmitter that it's affecting. It completely just left me. Do I have it right here? No, I only wrote GABA there. So even a small amount of alcohol will have those neural effects. So with that being said, you definitely shouldn't drive. So it's not healthy to drive and consume alcohol. But I mean, is it safe for a person? Alcohol is one that can be addictive, so I don't feel comfortable saying like alcohol, even in a small quantity, is safe, because if it's something that you're addicted to, that could be really bad. So a small amount, could it be healthy? I think probably the safest response is it depends on the study you look at. But in any case, it will have all of these neurological effects. It's still going to inhibit those GABA receptors and slow down that mental processing. So definitely don't drive. So yeah, maybe that didn't answer your question, but I think that's probably the best answer I can give. But all of these are examples of depressants. So there's alcohol, barbiturates, tranquilizers, and opiates. So with that, like it talked about in the video or in the mouse party, it's inhibiting a lot of the prefrontal cortex, and that's where we make a lot of judgments and where a lot of our inhibition is, so we can stop certain things. There's a friend that I had just met actually who, mentioning if you're alcoholic, not even having a little bit. There's a friend that I met who was alcoholic, but he had been sober for, I think at that point, 4 years. Now it's been like 6 years. It was at a research conference, and we were all going to go out to a bar and have some food, and some of us would drink. And so we invited him, and I didn't know he was alcoholic at the time. It was like my first day meeting him. And he said, absolutely not. I'm not going to go there. And then his other friend told me, oh, he's alcoholic. And it made perfect sense, because that kind of environment, the smell, it can be very triggering and very difficult. So, yeah. So with that, intellectual cognitive functioning can decrease. So don't drive, don't ride a motorcycle, don't use firearms and alcohol at the same time. All really bad ideas, all very unsafe ideas as well. So alcohol moves through this same kind of pleasure pathway that we've been talking about. So it's using the same neuron pathways for other pleasure senses. But like we saw in that mouse party, one of the main effects that it does at the neural level specifically is mess with those GABA receptors, makes them less likely to fire when the neurotransmitter GABA is there. So you think about that from the point of view of this entire network. If you're using a lot of alcohol, for example, then you've already got the first cell in sending a message is going to have a hard time. Let's say the first cell sends that message. The second cell in that network is going to have a hard time sending that next message. And then the cell after that has a hard time. And then the cell after that has a hard time. This is why things like the activity of your prefrontal cortex slowing down makes it hard to do things like making decisions, because the neurotransmitters are essentially needing so much more energy to actually fire, and they're based on this drug, they're less likely to fire. So with that, one thing that not everybody is aware of is that drinking to the point of passing out is actually a symptom of alcohol poisoning. So just like so alcohol is a poison, so you can clean and disinfect with it, right? So, but if you get too much of that in your body, it could kill you, like all at once. So drinking to the point of passing out is a symptom of alcohol poisoning. So the book and other doctors also recommend calling 911 if that's the case. So this is also why binge drinking tends to be really bad, because when people binge drink, they get to that point more easily. So it would be a lot safer to have one or two drinks in a day, well, depending on the size of your drink, I guess you could say. So the average size drink, it would be safer to have a couple drinks than to do binge drinking. And also younger people tend to be more likely to binge drink. So that's also problematic. So alcohol is the second widest used drug in the US. The first is caffeine. Caffeine is actually the most widely used drug across the world. And that tends to be about the experience in other countries as well. But yeah, in the US at least, caffeine is first, alcohol is second, and in other places in the world, caffeine is also the most widely used drug. So I just mentioned this. Many young drinkers or people who are drinking for the first time tend to binge drink. And so that is defined as 5 or more drinks in a row. So if you have a really tall glass of fruity juice with 5 shots of vodka, that would be considered binge drinking. Or I don't actually know, is a shot a drink of vodka? I forget the ounces that a shot is versus the ounce that is considered a drink of vodka. But essentially 5 or more drinks. So that would be 5 or more beers, 5 or more drinks of vodka. And with that, binge drinking, you are at a lot higher likelihood for alcohol poisoning. So here's that link to the mouse party again. So you can look up alcohol there. We watched that whole one, but if you want to look up other drugs that we're going to be talking about, it'd be a good place to do it, to get started. So we're not going to go into a ton of detail on all the different depressants, and we'll basically hit one in each category. So opiates are another example of a depressant, but they work on neurons in a different way. So they act on endorphin receptors instead of GABA receptors. So they're going to also do the activity of depressing activity in the central nervous system, and that can work to eliminate pain as one of the good things that it can do. So if you're using it in proper form as prescribed by a doctor. But so it's a depressant because it is depressing activity. It's slowing down activity that ends up slowing down that pain signal, right? So that's why it's considered a depressant, even though the experience of it, of a person using it, might be very different than alcohol. It's still depressing brain activity. So that's why it's here under depressants. All right, so stimulants. So these are kind of opposite of that. They are increasing activity in different parts of the brain. So at the neural level, they might be working on specific neurotransmitters. They might be working on specific areas of the brain. And you'll find that if you look into all the book goes into more detail than we are even going into here. They tend to work and affect specific areas of the brain and specific neurotransmitters each. Except for marijuana. Marijuana is a little interesting on how it actually affects the neurons. So we will talk about that one, though. So caffeine, like I said, is the most widely used drug in the world. I always feel when I'm looking at these pictures and talking about caffeine, I always want to drink my coffee while doing that. So probably some conditioning there, honestly. So with that, you'll feel your energy boosted. You might feel more alert. But the side effects, especially and withdrawal symptoms, can be unpleasant. So it can obviously change sleep. My wife, for example, she couldn't have a cup of coffee right now. It's too late in the day. She wouldn't be able to sleep for a couple hours. Like she would have some of those similar symptoms to insomnia. She wouldn't be able to fall asleep for a while if she drank some coffee right now. So it can change your anxiety level, your mood generally. Can lead to irritability, headaches, dry mouth, and digestive problems. So, yeah. It also affects the pleasure centers of the brain and can be habit forming. So it might give you that perception of increased energy and alertness, but these side effects too are not great. So obviously caffeine is another example of one that's legal, so use at your own risk. And know what it's going to do. So look at some of the other stimulants on Mouse Party and look in your book for more detail on what it's doing at the neural level. We're actually going to move on to marijuana and talk about what happens there at the neural level. And I think we'll watch the Mouse Party on it too. So hallucinogens are an entirely different class of drugs, and they modify perceptual experiences. So if you remember sensation and perception, sensation is seeing like the light entering your eyes and sending that message up to the brain. Sensation is the feelings of touch on your hand, sending that signal to the brain. Perception is then how do you interpret that? So hallucinogens can modify your perceptual experiences, produce visual and audio messages that aren't actually there. So audio hallucinations are actually more common, even amongst disorders as well. Audio hallucinations are some of the most common forms of hallucination rather than visual hallucination, which I don't feel like media really portrays that well. Like if you see someone in media who's using LSD or who is having symptoms of schizophrenia, you'll see them seeing things where it's a lot more likely to hear things that aren't actually there. So you're perceiving something. There's not actually the sensation of that going into your brain, but you are perceiving that because of what the drug is doing at the neural level. So marijuana can have a mild hallucinogenic effect. LSD has a pretty strong hallucinogenic effect. So the active ingredient in marijuana is THC. It doesn't actually affect a specific neurotransmitter in the same way as alcohol does with the GABA receptors. It actually affects the membranes of the neurons themselves. So every neuron is a cell, right? So it has a cell body. It has a membrane on the outside of it. It's got a membrane around the axon as well. And so it essentially, THC can affect the membranes of neurons, and that affects the functioning of neurotransmitters in a whole variety of ways. So this is why two different people who are using marijuana, who have different body chemistry, different neurochemistry, might experience the same, let's say, joint, for example, very differently from one another, because it is affecting the membranes of their neurons. And so in one person, it might have a stronger hallucinogenic effect, or it might have a very weak hallucinogenic effect. In some person, it might lead to more stimulant type feelings, versus another person might lead to more depressant type feelings, like slowing down neurotransmitters and the signaling. So stimulating areas of the central nervous system or depressing areas of the central nervous system. So for any given person as well, you can have different experiences using THC over time too. So because it's affecting the membranes of neurons. So I think it's really interesting that it's so varied. Whereas a lot of these drugs affect really specific neurotransmitters that do really specific things, and we can map those. Yeah, so that's a good example. So an indica versus a sativa, those are different strains. They'll affect the neurons in different ways. So, and even someone who uses that same indica at 2 different times might get a slightly different effect, both those 2 different times, or that sativa 2 different times might get a slightly different effect because of marijuana's effect at that neural level. So let's watch the mouse party for marijuana really quickly, and then we'll go on with the slides.
Before marijuana enters the system, inhibitory neurotransmitters are active in the synapse. These neurotransmitters inhibit dopamine from being released.
So that's the standard neurology in your brain, that there are inhibitory neurotransmitters to inhibit any dopamine being there in the synapse.
When activated by the body's own native cannabinoid, called anandamide, cannabinoid receptors turn off the release of inhibitory neurotransmitters. Without inhibition, dopamine can be released.
So that is a neurochemical that affects the dopamine, allows it to come out essentially, and some aspects of THC mimic that.
THC, the active chemical in marijuana, mimics anandamide and binds to cannabinoid receptors. Inhibition is turned off and dopamine is allowed to squirt into the synapse.
So this is the way that I felt like I just watched The Mandalorian, and then I said, this is the way, and now my brain is going other places. So sorry about that. I'm not using THC. I just get distracted very easily because of ADHD. So the THC is doing this effect to the dopamine neurotransmitters, but it also affects the cell membrane as well. So while there is this pleasure effect generally from THC, it can also make a lot of other things happen, like hallucinations, for example, because it's not only affecting dopamine, it can affect many different neurotransmitters because of how it affects the cells and the cell membranes. So if this membrane here is affected and more chemicals are allowed to be released or enter in, then it can have a whole other host of effects of neurons sending other signals that it wouldn't normally send.
Anandamide is known to be involved in removing unnecessary short-term memories. It is also responsible for slowing down movement, making us feel relaxed and calm. Unlike THC, anandamide breaks down very quickly in the body. That explains why anandamide doesn't produce a perpetual natural high.
As opposed to the THC, which can produce that same feeling that the anandamide would produce for even up to a couple hours. So the physical effects are increased blood pressure, pulse, can have coughing or dry mouth, especially depending on how the marijuana is being used. So psychological effects, because it's affecting that membrane, can be excitatory. So cells are more likely to fire, not just the dopamine receptors, but other messages are more likely to be sent, can be depressive, so cells are less likely to fire, more similar to alcohol. And you can even have effects that are mildly hallucinatory. So, like I said, more likely for hallucinations to be auditory, but they can also be visual. So with that, people tend to have increased sensitivity to sounds, tastes, smells, colors, and so that's part of that perception being changed. So the sound isn't actually being sensed differently, but it's being perceived differently when using a psychoactive drug. So it can trigger spontaneous, unrelated ideas, distorted perceptions of time and place, feelings of, say, lost time or time moving different than it actually is. With that, it can be used really effectively to treat a lot of different medical symptoms. So one common problem with people in chemotherapy and many other things is that they have a lack of appetite. So it can help increase their appetite. So you might have heard of munchies as a common thing that people who are using THC might feel. So that munchie side effect is actually really useful for someone who is on chemotherapy and does not have an appetite. So it can be really effective at treating some seizures. Like some types of seizures it won't affect, but there are certain types of seizures that it can really help reduce the problems for. Pain reduction as well as nausea, it can really help with those things. So with that being said, it might be damaging to the prefrontal cortex if used before about the age of 23. And so we talked about that age of about 23 as when the prefrontal cortex finishes its myelination. So essentially, there's some research that suggests that marijuana might be damaging to that process, so that the myelination doesn't happen as thoroughly or as quickly or as well. And so the person's cognitive ability might be a little lower than it would have been without the marijuana. So that being said, I've got a couple links after this. That being said, this is, well, we know what that part of the brain does. So this is something that's seen. Again, these are correlational studies. It's really hard to do these kinds of experiments with marijuana. There are more happening now, though, especially since it's a legalized medicine in so many places. So there is more study of it to see what these side effects are. So I think we'll have better data on, is it damaging, is it not damaging, those kinds of things, pretty soon even. But this has been seen with people who are regular users over a long period of time. So a heavy user is someone who's using THC 5 to 7 days a week, and they're at much higher risk for this. So if you know someone, if you have a friend that is using THC 7 days a week and they're 16 years old, maybe suggest that they use it half that, and then there'll be a lot lower likelihood of having any kind of neural effects from it. So here are a couple links to those articles that talk about this, and as well as the Mouse Party link there. So if that's something that you want to do a question paper on marijuana, because there is a lot of new research coming out about marijuana, about the effects of THC at the neural level. So if that's something that you're interested in learning more about, here's maybe a good place to start for some articles. And then I'm sure you can find a lot more new articles as well. So as an example, what I'll tell my children, here in Utah, it's not legal for recreation, but it is legal medicinally. So if we were living, say, in a place where it was legal recreationally, I would suggest to my kids not to use it before they get to be about 23 is what I'll suggest to them. We'll see if they listen. That's what I would suggest to them. Yeah. Questions about marijuana? I know we're kind of skimming over a lot of other drugs, so we're not going to go into detail on LSD as well. We'll jump over to other conscious effects of consciousness from hypnosis and meditation. So oftentimes I have students asking me, and especially since I think Oregon just allowed medical use of psilocybin, I think it was. Students also often ask me about that. I am definitely not up to date on the research there, but since it is being used as a medicine in many places, I think the best thing to do would be look for the most recent research, similar to how you look for them for your question papers. Just go to Google Scholar, go to PsycInfo. If you go to the library website, you can find the research database. Look for medical journals. There are journals that talk about trials for these different drugs and substances. So do your research to find some of the most up-to-date things. You're learning the skills now to be able to learn and read those kinds of research reports. So you don't have to go to, say, a news report talking about it. So you can essentially learn it from the source, learn it from the scientists who are reporting on it. Because one thing that you might find as you do that is that a lot of just journalists who are reporting on the scientific research, they might not always understand. And that's kind of one of the problems of scientists trying to put their research out there in a way that can be understood by journalists, as well as just scientific literacy of journalists is not always as high as even for students who have this assignment to do a question paper. So you're gaining those skills to be able to go to the scientific source and learn about it. Again, I would still say probably skip at your level the methods and results, maybe the methods, but probably skip the stats and the results. But going over the abstract, intro, and discussion could be really useful to understand what researchers are saying. So got a comment on, heard that they discriminalized, I don't think that's a word. So decriminalized all drugs. So yeah, that's a good question. I think hopefully we find out soon. Hopefully it's a nice, I mean, in a way, it's a nice way to be able to do research on that. It would have been really hard to do ethical studies on marijuana, for example. 20 years ago, it was really difficult to do any studies on marijuana. You could only do these kind of correlational studies because it was an illegal substance, even as a medicine in many places. But in the last 5 or 7 years, so many states have legalized recreational and medicinal use that more research can now be done on these substances. So I do hope that it'll probably take a year at the shortest would be my guess to get some good data on what if this decriminalization is doing and what these substances can do as medicines, especially since it seems like in many cases the substances are going to be used by people just themselves rather than like as prescribed by a doctor in a more systematic way. So hopefully we can get some good systematic causal data from experiments. Because in that case, if you're wanting to check what psilocybin does, for example, you need to have a control group who's not using it. You need to have a treatment group who is using it, and maybe even a couple treatment groups, one using it at a low level, one using it at a high level. You need to be able to have enough people that for that you would probably want volunteers. So you need enough volunteers that are similar enough to a population to be able to make good causal data, and that can be difficult because you're kind of limited from the beginning by people who are already maybe even thinking of using, say, psilocybin or marijuana to treat whatever it is. So yeah, it's not the same as, say, a randomized controlled trial for, some drugs you can do, you kind of have that same problem too, is you're kind of limited to the pool of people with the problem or disorder that they're trying to treat with that substance to do that experiment on. That's why sometimes you'll see in medical journals, some of their cases are 12, 32, 56 participants who are in the experimental group. So yeah, hopefully we do get some causal data soon so we know if this is a good idea. Should other states follow suit and do that kind of thing? The decriminalization goes beyond just the using as a medicine, but since we're talking about medicine specifically here. So other questions about any of these substances? So like I mentioned earlier, one thing that I kind of want to hit home is that many of these, most of these drugs, most psychoactive drugs on this list, for example, are affecting specific neurotransmitters. Really, the only one we talked about that is doing something kind of dramatically different is THC, which I find interesting, that it can have so many different effects. All right, so yeah, so decriminalizing allows for things like rehabilitation programs to be set up instead of just sending addicts to prison. Yeah. So I wasn't going to talk about that specifically in relation to this, especially since that seems more like a social psych evolutionary or evaluation thing to go into, since we were talking about it as a medicine. But yeah, it allows the opportunity for these to be used in other ways, and check and maybe get some good causal data on what kind of benefits they can have. Yeah, really good point there. All right, so hypnosis is another maybe altered state of consciousness. That's one of the controversies in relation to hypnosis. So, with this, it may be an altered state of consciousness, or it might be just an altered state of attention from the individual. But in any case, it seems like the person is more receptive to suggestions. So with it, when looking at EEGs of people who are under hypnosis, as well as people who are at different levels of consciousness, sleeping, waking, the EEG is really similar to someone in a relaxed waking state, so not a sleeping state. There is this debate on, is hypnosis truly an altered state of consciousness, or is it something different? So I'll give you some evidence both ways here, and maybe you'll decide yourself which one it is. I'll probably tell you on this what my take is here too. So there are generally 4 steps that a hypnotist takes. So you may have seen a hypnotist at like a stage show or something like that. Really interestingly, it was actually here in Utah. I was in middle school here. It was actually in Summit County. I don't know why. I don't remember the relevance for this. But for like an end of the year assembly, they had a hypnotist come and hypnotize some students. So I always wonder why is that? Is it just because it was the end of the year and the teachers were like, oh, this might be fun for students? One of my friends, he actually was hypnotized. And so this was the steps the hypnotist took in that process. I've seen hypnotists / magicians do this too. But if you're doing hypnosis in a therapeutical context as well, they would take these same kind of steps. So first, minimizing distraction, trying to make a participant comfortable. That's a lot harder in a big assembly with middle school students at the end of a school year. But in a therapeutic session, this is probably going to be a very easy task to do. Tell the person to concentrate on something specific, like an imagined scene. You've probably seen the watch going back and forth. Anytime I've seen hypnosis, I've not actually ever seen them use a watch, except for like a joke at the beginning of their act, essentially. So concentrating on something specific. You do something similar for meditation as well. So in some ways it's similar to that. So concentrating on something, and inform the participant what to expect during the hypnosis. Like they'll be relaxed, they might hear the person's voice, they might still be able to know what's happening around them. And then finally, they will even suggest events or feelings that the hypnotist knows will happen, or that they even see happening right then. And that's one key part of it too. So saying things like, your eyes are getting tired, as a person's eyes are getting tired, gives that association. That's conditioning there. So if your eyes are getting tired, if they're starting to close as you're getting relaxed, and the hypnotist says that, it makes the person, it doesn't always, it can make the person associate that the hypnotist is actually doing that, causing that to happen. So when suggesting that kind of thing, like you're getting sleepy or your eyes are getting tired, that reinforces that idea that the hypnotist can cause that change. And that increases your expectation that the hypnotist later on can cause more things to happen too. So, well, I'll tell the story about what happened to my friend. So, he was up there with 4 or 6 other students. I don't know, memory, you know, I don't. It's not a film strip. I can't remember it in tons of detail. So my friend was up there getting hypnotized and was told by the hypnotist to all these people, you're getting sleepy, you're getting tired, you're getting relaxed. Then he went one by one and kind of gave them a task to do under hypnosis. One was supposed to act like a chicken, and then my friend, he was supposed to feel like his feet were stuck to the floor when he stood up. So you'll feel like your feet are stuck to the floor when you stand up. You won't be able to walk or move. So after that, after he gives everybody their instructions, he claps or snaps his fingers or says whatever keyword he was going to say. And so this is what happened. The person next to my friend starts moving his arms like a chicken, starts clucking, and it's pretty funny. This is why I think it's so strange that this was in a middle school. Middle schoolers care a lot about what their peers think. Peer relations are very important to them. Embarrassment can be really difficult, and it can be really difficult to stand out from a crowd in middle school. So to literally set up a situation where these like 4 or 6 students were having this kind of strange thing and having all eyes on them, it just seems like a strange choice to make to me. Anyway, so my friend does stand up. He stands up from his chair and he almost falls down on the ground because his feet are not moving from the ground. So it's working. The hypnosis is working. He wasn't able to move. He looked very confused. He looked like towards me with this confused look on his face, and I was just laughing at him, which maybe not the greatest friend. Maybe I shouldn't have laughed at him. And then looked at the hypnotist, looked at the other students in the room, and we all knew what was going on. He was hypnotized to think that his feet were stuck on the ground, but his feet wouldn't move, and he didn't understand why. So why did that happen? Was he actually in a different state of consciousness? Well, let's talk about some of that. So there is a debate if hypnosis is an altered state of consciousness. Hildegard was a researcher and hypnotist who thought that consciousness was divided when someone was under hypnosis, that there was kind of a hidden observer, and that was like where our true consciousness was, but that our other conscious piece, that other half, was following the hypnotist's instructions. So that might be something that could be tested for more scientifically now than it was able to back then, with brain scans, for example. Others think it might be more of a social cognitive behavior. And so not a change in consciousness, but that you essentially know what people expect from a hypnotist. You yourself expect like this situation to go in this specific kind of way. And so based on what you understand, your cognitions about this, you kind of follow along with that social cognitive behavior. So people learn how they should act during hypnosis. I mean, the hypnotist literally tells you kind of what you should be expecting, right, beforehand. So even if it's new to you and you haven't seen it in films and movies, if you trust that person as an authority, then you might behave that specific way. Not because of a different conscious state, but because of this social situation, that's how you're supposed to behave in this situation. So with that, what is the evidence for these things? So what is the evidence that it's a different state of consciousness? Well, when I asked my friend later on, or when you ask people who are under hypnosis to talk about it, they talk about not being able to control themselves. Well, some might. Some say that they knew what they were doing, and so doing those interviews isn't the best source of data. But people are suggestible, right? When people can be reinforced. People can learn how to behave in a specific situation and then go along with that social situation. That's what social psychology looks at. That's literally what its foundation is how do social situations affect the behavior of an individual. So this could be just one example of that. But there's also these pieces of evidence. Hypnosis is used to reduce pain. So there are dentists who, especially if someone's allergic to anesthesia, they might use hypnosis to reduce the pain of someone getting a tooth removed or getting a cavity drilled. And so that those people do report not having pain or having less pain than they would have otherwise when this is done in like randomized control trials. So a causal experimental testing. They do see reductions of reported pain. Um, Hypnosis is used in cases of PTSD to help work through triggers and traumas. Hypnosis does work to help with suicidal tendencies, depression, alcoholism, overeating. So, is it an altered state of consciousness or is it a social cognitive behavior? Well, I'm definitely a little more on the camp of social cognitive behavior in a lot of cases. So I think especially the cases I've personally observed that are more like kind of a party trick or a show kind of thing, I think a lot of that is probably more likely a social cognitive behavior. Um, but I think there is something to it that maybe it's not an altered state of consciousness, but there is some kind of physiological effect. Otherwise, we wouldn't see this reduction in pain. We wouldn't see it help for people who have a problem with overeating to be able to go through hypnosis treatments and then not have that problem overeating or have it be diminished. So, but it is interesting. Is it an altered state of consciousness? Is it a social cognitive behavior? In one case, might it be one? If for two people who are undergoing the hypnosis, for one, might it be social cognitive behavior, and the other, it might be actually affecting consciousness? I think it's probably some kind of mix or range of those things, but I'm definitely a little closer on the social cognitive behavior camp myself. So, questions about hypnosis then? All right, so meditation is another thing that we'll talk about in consciousness that, similar to hypnosis, is different than our general waking brain waves when you look at an EEG, but not as different as, say, N3 sleep. So meditation is when you attain a peaceful or focused state of mind where, oh, there's a N missing there. So where thoughts are not occupied by worry. So it's similar to different parts of your brain are active during meditation that are not active during sleep. And there are certain parts of your brain that are active during sleep that are not active during meditation. So there are some similarities to the EEGs of someone who is sleeping as well as meditating, as well as someone who's relaxed and also meditating. So if you compare someone who's relaxed and meditating, some aspects of their brainwaves, some aspects of their neurological activity are going to be similar. Someone sleeping and someone meditating, some of their neurological activity will be similar. For meditation, there is generally more activation of the basal ganglia and the prefrontal cortex than there is when sleeping. But there's less activation of the anterior cingulate, which is where acts of will or like going and doing something, that kind of agency and choosing what you're going to do kind of stems from. So there's a couple different kinds of meditations. We'll talk about a few of them, but there are others. We'll focus mostly on mindfulness meditation, but loving kindness meditation is a type of meditation that attempts to develop an acceptance and love of self and others. So it kind of starts with you could think of it as an expanding circle of care and concern. So first, this practice would try to get a person to love and accept their own selves or aspects about themselves, especially in like a therapeutic setting, maybe aspects of themselves that they don't like, for example, and then start to expand that circle of acceptance and love to other people. So it might be really easy for maybe a person to love themselves, but maybe they have a hard time with that kind of empathy or care and concern for other people around them in their life. So you might start with even a pet, like maybe it's easier for them to have that loving concern for a pet. So during a meditation session, you focus on that thing. So you focus first on developing those feelings of warmth and acceptance towards yourself, then extend that to maybe a circle of nearby close friends and family. You can move it to, say, acquaintances, coworkers, and then people generally. So there's been research on loving kindness meditation in relation to prosocial behavior, which is where I come in connection with this, to see if loving kindness meditation can increase prosocial behavior. It definitely does seem to increase empathy and social responsibility, and depending on the study, it in some studies it does seem to increase things like volunteering behavior or donation behavior over a group that did not do a loving kindness meditation. So with that, some of those were short trials versus loving kindness meditation wouldn't be necessarily in one sitting. You'll go from loving yourself to loving everybody in the world. It would be like over the course of months to even years, you would go from learning that warmth and acceptance of yourself and then expanding that slowly over those courses of months or years to expanding it to many other people. So the longest meditation studies for loving kindness and prosocial behavior that I'm aware of were like 16 weeks. So what would the effect be, or what kind of effect on prosocial behavior might we see if they were longer than that and they followed people who kept up with their loving kindness meditation longer than that? I'm not sure. It's a good question though. So one thing, an additional thing is, as well as possibly increasing prosocial behavior, it does seem like it might help combat prejudice. So prejudice attitudes are reported lower than they were. So you take a bunch of people, they might score medium or high on prejudice attitudes. Then after the loving kindness meditation, those 16 weeks, those scores are lower. So less prejudice, less discriminatory behavior, those kinds of things. So that's also great. So mindfulness meditation. So this is focusing on being mindful of essentially everything. So, but mostly things in relation to your body, your own sensations, your own perceptions, your own thoughts, your own emotions. So with that, when doing the practice of mindfulness meditation, you'll often focus on your breath while sitting or even lying down. You can do mindfulness meditation while walking. So say do a meditation session while walking through a park or a forest. So essentially you kind of focus on whatever you're focusing on, your breath, maybe a candle, maybe a tone. Very often it's the breath though, because that's something you have with you all the time. It's a useful thing to focus on. It's got a cycle and a rhythm so you're breathing in and out. You can focus on the feeling of the air in your nose, out through your mouth, those kinds of things. But as you're doing that, you let these other thoughts just kind of pass. You let your emotions just happen. You don't try to like grab onto them. You don't try to interact with them. So it's as if you were sitting on a bench on a street and people were passing by you. You don't like grab that person and like pull them over and interact with them. In the meditation, you just let that person pass by. So there might be a scary thought or a scary person, like a thought that you don't like. So rather than trying to push that thought away, you just let it go by itself. So hopefully that description makes any sense at all. If you've done meditation, it probably makes sense. Marissa mentions your breathing sounds a lot like waves at the beach when you're meditating, which is really cool. Yeah, I guess it could that way as well. Or you could even focus on the sound of a beach. So one thing that I did early on in my graduate student career was look to see if mindfulness meditation specifically could increase prosocial behavioral tendencies. So we created a short meditation exercise, and we did find that it did increase mindfulness and did decrease stress, but that effect only lasted a few minutes. So our experiment, though, was essentially you either watch this video, so the treatment group watched this video, the control group watched a video of a tour through a brewery. So both videos had, I'll give you a little bit of methods background here. So an experiment, when you're doing an experiment, you need at least two groups, right? So our two groups were a group that watched the mindfulness video. The second group was a group that watched a brewery tour. So, but the brewery tour versus the mindfulness video, they're different in a lot of different ways, right? So you want to make sure that the mindful exercise is the thing that leads to increased mindfulness, and not that the brewery tour made people more stressed or less stressed. So first we did a pre-test. We checked what their mindfulness level was before they did any videos. We checked what their stress levels were. We checked their intentions to behave pro-socially by asking them, like, would you behave? Well, we didn't use the word pro-socially, but how would you act in this kind of situation, to see what they might do? Would they act pro-socially or not? So we measured a couple other things too, like well-being. That didn't show any change over the short meditation. Then the meditation is 7 minutes, I want to say, and the brewery tour was also 7 minutes. So we wanted to make sure it wasn't down to the length of the video. They're both within like 10 seconds of each other. So we tried to take that as a variable out of the situation. Another thing was the speaker. The speaker on the meditation sounds female, and so we got a brewery tour that was led by a woman as well. So the voice was similar enough, but obviously the visual experience is very different. A brewery tour versus meditation. The things they're talking about are different. So could we have used additional control groups or additional comparison groups with other 7-minute videos? We probably could have. And that would have made the experiment a little bit stronger even. But that's some of the methods that went into just this one study, to give you an idea of how studies are actually done. What we'll do is we'll try to do this short mindfulness meditation. It's a guided meditation, which means the person speaking will kind of lead you through doing specific things, will tell you to do things. So, I mean, you don't have to participate. You can take a break. Right now, I think after we finish it, we'll actually take a couple-minute break. So I'll turn off the video and then I'll mention in the comments like how long our break will be now. Yeah, so follow along with the video, pay attention to your breathing, pay attention to the things that they say in the video, and we'll see how you feel from before the video to after the video.
On a chair or on the floor. So find a relaxed, comfortable position, seated, on a chair or on the floor, on a cushion. Keep your back upright.
Sorry, I'm trying to change the settings, so even though it looks like the internet is running a little slower right now, we won't have any more pauses after I get it actually started. All right, so we're going to start for real now.
So find a relaxed, comfortable position, seated on a chair or on the floor, on a cushion. Keep your back upright, but not too tight. Hands resting wherever they're comfortable. Tongue on the roof of your mouth or wherever it's comfortable. And you can notice your body from the inside, noticing the shape of your body, the weight, touch. And let yourself relax and become curious about your body, seated here, the sensations of your body, the touch, the connection with the floor or the chair. Relax any areas of tightness or tension. Just breathe, soften. And now begin to tune into your breath in your body, feeling the natural flow of breath. Don't need to do anything to your breath. Not long, not short, just natural. And notice where you feel your breath in your body. It might be in your abdomen, it may be in your chest or throat, or in your nostrils. See if you can feel the sensations of breath, one breath at a time. When one breath ends, the next breath begins. Now, as you do this, you might notice that your mind may start to wander. You might start thinking about other things. If this happens, this is not a problem. It's very natural. Just notice that your mind has wandered. You can say thinking or wandering in your head softly. And then gently redirect your attention right back to the breathing. So we'll stay with this for some time in silence, just a short time. Noticing our breath, from time to time getting lost in thought and returning to our breath. See if you can be really kind to yourself in the process. And once again, You can notice your body, your whole body seated here. Let yourself relax even more deeply. And then offer yourself some appreciation for doing this practice today. Whatever that means to you. Finding a sense of ease and well-being for yourself in this day. So find a
All right. Well, thank you for anybody who did go through and do that. Oh, accidentally turned it on again. We'll just do that. So thank you for anyone who did go through and try that meditation. Let's get some comments about what that experience was like for you. Have you done meditation before? What were some sensations or thoughts or emotions that passed by as you were trying to do the meditation? Did you feel more relaxed? Do you feel more relaxed now than you did before? Those kinds of things. While you're typing, you can also raise your hand and take over the mic as well. I see a hand from Adam. Go for it.
I was just gonna say, like, it kind of almost made me fall asleep. I'm actually I'm on campus right now because I have a class here afterwards. But like halfway through, some people started doing some work on some chairs, and they're using like drill bits and stuff. So that was really distracting.
Yeah, really good example too of feeling more relaxed and even feeling a little sleepy. So one thing
Yeah.
that meditation can be really useful for is being more mindful of your body. So essentially the thing that people will say is if you're feeling sleepy while meditating, probably means you need more sleep, which I mean, for probably all of us that are in college, that's probably the case anyway. So it's good that you recognize that though. And it can be difficult. So finding a place or a space where you can meditate without those kinds of distractions, or getting practiced enough with it that you can still meditate in that kind of situation, is a really good thing to do.
Yeah.
Useful. Yeah. Any other thoughts or emotions that you had, Adam, while you were going through the meditation?
What was that?
Did you have any other thoughts or emotions that you wanted to share about it?
No, just that I was really relaxed. I love meditating. I do meditate quite a bit.
Mm-hmm.
So
Great. What do you usually do? Mindfulness meditation or another style?
I don't really like know exactly. I just kind of try to tune all my thoughts out and just be at peace with everything and be in tune with my body.
Awesome. Do you use things to focus, like a sound or an app or anything like that?
Yeah, I usually look up like YouTube videos
Mm-hmm.
that have nice calming sounds to them.
Yeah, perfect. Well,
So
thanks. Awesome. Thanks for sharing, and thanks for participating as well.
yeah.
So I see another hand from Kelly. Go for it.
Oh, for me, it made me think of Shavasana during yoga. So you're laying on the floor and you just have to lay there and breathe for a while, except you're sitting up. And I was just like thinking, I'm like, I'm gonna think about my dog. So I was just doing that the whole time while breathing,
Mm-hmm.
which was
Yeah.
nice, very relaxing.
Mm-hmm. Definitely. And you can definitely add meditation specific, like as the focus while you're doing yoga as well. You can do mindfulness meditation also while, say, doing a walk too. So you don't necessarily have to close your eyes for it. So I wouldn't recommend closing your eyes and walking around, but you could probably close your eyes while doing yoga.
Mm. Well, you're standing in one place, so I close my eyes during yoga sometimes, unless I need to see what position I need to go into.
Yeah, for sure. With that, so it's similar to when you're doing yoga. Have you ever tried meditating on its own before this
Uh,
time?
really no. Generally no.
Yeah, no problem. Yeah, thank you for sharing as well. And I saw we had some comments as well. We had Marissa saying, feeling very relaxed and kind of heavy, like you're sinking into your chair. Yep, especially when sitting up rather than laying down, I often get a similar kind of sensation to that. Kebron is saying, I use meditation to feel more grounded and relaxed. It helps focus and clear my mind. Yeah, that's a really common experience people have. It's one reason I sometimes recommend doing meditation right before something like an exam. So it can make you a lot more relaxed, a little more calm, especially if you are very stressed about an exam. So Shay says, I took a mindfulness class in high school, and it was probably your favorite class. Well, that's great. Doing meditation every day, bringing compassion, self-compassion, and being aware with it. Nice. So it sounds like you were probably doing a couple different kinds of meditation in your class as well, if you're bringing compassion, because I mean, you can definitely mix these as well. So great. Thank you all for sharing. So hopefully if this is your first experience with meditation, you kind of understand a little bit more about what it is, what it does. So like I said about that little meditation video that you saw, we saw in an experimental setting that it did make people feel a little decrease in stress and increased mindfulness. So they're more aware of themselves, their surroundings, their emotions, those kinds of things. So you might have experienced that, you might not have. So guided meditations are really useful if you want to get started with meditations, and you can find a lot on YouTube, or there's a lot of different apps. So we wrote a paper writing up these results and tried to publish it. The reviewers and editors came back and they didn't actually really like this paper at all because there's a couple really popular meditation systems, and they take about 16 weeks to complete. And so a lot of research on the benefits of meditation are on those 16-week courses, which cost some money, take a lot of time. So we were coming in saying, hey, we wonder if you can still get some of that benefit with a really short meditation that is really accessible to someone who's never tried it. A free YouTube video that's a guided meditation, for example. So essentially their main argument was that it's not a good enough rationale to test this really brief one when we already know that we have these long ones to study. So I feel like it's kind of hey, we're stepping on their toes kind of thing. But one of my co-authors was just talking to me last week and saying that she wants to try and republish this paper because we did find these effects in a couple different experiments that it did work. And so I think there's enough apps and guided meditations out there now that I think we could make the case a little more strongly that it would be useful to know in general, not trying to promote this specific YouTube video, but we want to see, hey, is there effects of these short mindfulness trainings? Because it seems like there are, based on our experimental results. And then I think we just have to increase the thing that says, hey, this doesn't take the place of those 16 week courses that cost a couple $100s to take. So I think they felt like we were stepping on their toes a little bit. Sad because it's science. You should be able to publish good stuff like that and not have editors who have some kind of vested interest. But that happens even in the sciences. That might not be the only reason, but from their comments, that's what it felt like was their biggest pet peeve of it, was that we have these big systems, we know a lot of the benefits, there's not really any good reason to know about the benefits of this short of a short exercise. So that is all on this chapter. We're going to jump in just a few minutes to chapter 8 on developmental psychology. So first, don't forget to take the SmartBook quiz on this chapter before midnight tonight. And let's take a quick break. Let's be back at 4:33. So be back here in the general classroom at 4:33, and we'll jump into developmental psychology.
Well, Taylor, don't worry. Just have fun on your date. If it doesn't work out, you can get another guy. You're that kind of person. You'll have another person. So just have fun. Sorry, I'm just teasing you with the song before. Well, Taylor, don't worry. Just have fun on your date. If it doesn't work out, you
All right, and we are back. So we'll jump into chapter 8. And like I said, chapter 8 is kind of a dense chapter. There's a lot packed into a short space. It's also one of the areas I'm more expert in. I know a lot about developmental psychology since that's literally my degree. So it might be that feeling why there's so much stuff just packed in, and we should talk about it more. But either way, we're going to spend a little bit of extra time in chapter 8. So, as a reminder, these are the groups. Talked about this earlier in the class. If you are not already signed up for a group, make sure you get into the teams, send messages to other people. You can even see in those teams, in the groups, who's been working on it. So anybody new to the groups can send emails to people saying, hey, on Canvas, for example, in the to line, if you just start typing a student's name, it should be able to send an email to them in Canvas. So go ahead and get in contact with people, jump into groups, and we'll get that group assignment going. All right. So one of the first things to make a point of for developmental psychology is modern developmental research takes the lifespan perspective. So that's the idea that development is happening continuously from conception all the way to death. And development is defined as a pattern of change. So there are certain changes happening here in the infant stage. There are other changes happening in adolescence. There are other changes happening in late adulthood. So that change over time is happening all the time. So you can track people's physical change over time, their socio-emotional change, all kinds of change. So why do you think it'd be important for you as students? On average, the range of student ages at Salt Lake Community College, a lot of them are just under 18 to early 20s. So why would it be important for you and students in the class who are older than that as well to study development through the entire lifespan? Maybe no one's back from break. Well, that's the hard thing, right? I don't know if nobody's talking and answering the question, or if nobody's there. That can be tough sometimes.
Or did you accidentally have the mic on now and not earlier?
My passive aggressive comment got some responses, or you were just typing already and I spoke too soon. So you can better understand yourselves. Yeah, exactly. So even though you might be out of childhood, out of adolescence, some of you might still be in late adolescence and in early adulthood, to understand what part of development you're in, but also understand what might be coming up in life. So those are some of the big things for studying development. Maybe some of you have children or will have children or will interact with children in your occupations even. Probably all of you will work with other humans in whatever occupation you're in. So they'll be at maybe similar developmental level as you, or they might be in late adulthood. They might be anywhere on that spectrum, right? So yeah, to understand yourselves better and understand other people better too. Hopefully some of you even started this psych course to just understand people better. All right, so research used to focus a lot on early childhood. So the first 5 years especially, and that might be your primary interest in looking at development as well. You might be most interested in the development of children, but we know now there is a significant amount of change all throughout adulthood. And that's not just decline. It's not just like physical or cognitive decline. There's a lot of changes that are still happening throughout adulthood. So similar question, how might knowing more about adult and late adult development affect you? And I feel like the answers we got kind of answered that as well, is that because this is probably the span of time that most of the students in the class are in early adulthood. So understanding adulthood and late adult development is something that you will experience in your lives. So development is lifelong is the first primary point I want you to take away from this. This is essentially things I'm bringing to you about developmental psych that are beyond just the book text. But modern research looks a lot at lifelong development. Development and developmental research is also multidimensional. So it's not actually this kind of multidimensional like Doctor Strange or Spider-Verse kind of multidimensional, but they're fun pictures to include in the slides. Maybe they catch a little bit more attention. In reality, it's more multidimensional like this. People have biological dimensions to themselves, their own genetics, for example, health challenges, hormone levels, things like that. Cognitive dimensions of themselves. So can they think quicker or slower or solve problems quicker or slower than other people? Socio-emotional dimensions, personality. So you can think of any given person as a system of development. So this is a part of a model of human development. And so you've got a child here. You could think of this as yourself or any other person, an adult even. They have their own biology, their own health, their own demands on themselves, their own temperament, personality, behavior. So all those things are dimensions of that person. So development tries to look at all those different dimensional or at all those different dimensions. And development is also multi-directional. So there's things like in spring, you've got leaves that grow and sprout from trees. In the fall, you have those falling off the trees. So change happens in different ways at different times in your life. And it's multi-directional. So the dimensions or components of any person's life can grow or shrink during certain times. So the capacity to learn language is a really good example of this. We are genetically and biologically pre-programmed to learn language early on in life. So it's really easy to teach multiple languages to young children. So if a child is in a bilingual or even trilingual house in childhood, they will very quickly and easily pick up those multiple languages. Versus myself in high school, I took French to try and learn French, and it was not easy. It was very difficult for me. I passed that key point where I had that greater capacity to learn language. Obviously, it is still possible to learn languages after that time, but it's not as easy. I was no longer biologically predisposed to be learning languages. Development is relatively plastic. So we've talked about plasticity in neurology. You see these little pictures of neurons here. So plasticity basically means the capacity for change. You could think of plastic or rubber as being kind of mobile, kind of movable. So, like this joke, you can teach an old dog new tricks. People have a great capacity for more plasticity in their life, more change. So older adults specifically can master brand new cognitive skills that they never had before. Even though they might be losing some physical capacities, they can gain a lot of new cognitive capacities if they work on them. So a lot of plasticity comes just naturally, just the things we're doing will tend to be able to learn and do them better. Especially at the neural level, our neurons get used to doing things. I think we used the example of working out. That initial burst of strength when you first start lifting weights comes from neural plasticity, that you're gaining new dendrites, new axon branches to tell more muscle cells to contract when doing an exercise. So almost everything can change with people at every point in life. It's not everything, but almost everything can change. So development is multidisciplinary. So we're in the psychology course, but what other disciplines look at human development? Can you just list a bunch in the chat? So what are some other disciplines that care or are interested in human development? Social workers is a great example. So are teachers. They both are working with people at different stages in human development, and they need to know about human development, education research, research on treatments for people who, and for things that social workers are doing, care about human development. Healthcare workers, so whether it be nurses, OBGYNs, doctors, they're all interested in people's bodies changing over time and even their mental health, right? Parents, yeah. So a lot of examples, so really great examples on other disciplines that look at human development. So with social workers, I'll also extend that to sociology. So healthcare workers, as well as other medical professionals, OBGYNs, we have that example. So also we have, oh my goodness, I just forgot the discipline. I think it's on my next slide though. Anthropology, that's what I was trying to think of. So anthropologists are also interested in human development. So neuroscientists are interested in human development. So I'm a psychologist. That's what my degree is in. That's what my focus is in. Some of the people I work with are also psychologists, but some of them are also sociologists. A lot of them that I work with, one of the closest connections with some of the work I do are actually neuroscientists as well. So working with people from these other disciplines is really helpful for building knowledge about human development, because I don't have, at my labs, I don't have access to a lot of neuroscience measuring tools, and that wasn't the expertise I was trained in. So working with another person interested in the same topics as me, who that's their background in neuroscience, looking into how heroes develop and how people develop their pro-social intentions is really useful and interesting. So depending on what you're trying to learn about humans, other fields might be trying to learn it at the same time. So we as psychologists need to look at development through this multidisciplinary lens. It's not all just our responsibility. We also need to work with these other people to do that. Stephanie Preston is one of those colleagues that I mentioned who studies mammals specifically and other animals too, and looking at, do these other animals demonstrate altruism? And there's a lot of evidence that she's published that yes, they do demonstrate altruism, and there might be some evolutionary roots to doing altruistic behavior, which is pro-social behavior that is intended only to benefit the person that you're helping, or that the rat is helping, and is not intended in any way to benefit the actor or the person doing the helping. So that's altruism. So development is contextual. We saw that multidimensional individual with here. So we had this little zoom in on the child or the adult. It's also contextual. And context basically just means setting. So you've got your school network. Here we're in a school kind of setting. A child might have parents. You might have parents. You might have a partner. That would be another circle here. The social network. Your relationships, a work network. So there are these other settings that affect your life, that affect your development over time. Your community is a big part of it, the society you live in and the culture. So as an example, the broader society here in the US right now for the past couple days, no matter what kind of side of the political spectrum or which corner of the political compass any of my friends are on social media, a lot of them are kind of like just stressed out and anxious and awaiting election results. So sorry if you had forgotten about that for a few minutes. I wonder if there are any more results right now. Now I just made myself think about it. I didn't actually check during our break, so I have no idea. So with that, that's an aspect of the community that's affecting how we develop, right? So that stress might affect how I'm parenting my kids. Depending on the results, might be more or less stress, and that will affect how I parent my kids. So these immediate networks have these bidirectional interactions. If I'm stressed and I interact with my children in a more stressed manner, they'll probably get more stressed out too. And then it might be kind of a downward spiral. So if I'm less stress and So if I'm less stressed and parenting my children with less stress, maybe they'll have more positive interactions. And so we'll have more positive interactions. Maybe it'll be more positive upward spiral. So the settings that you're in will affect how you develop at a really tiny level, like individual moment to moment, but also broader level, like over the course of a year. And the change in it that a child has. Another example of the community's change, my daughter's been doing school from home online, just like we're doing here right now. And so that context, that setting is different. Is that having a more positive or less positive effect on her schooling? Yeah, these are how settings affect development. So, all right, development also involves not just growing things, but also things being lost and maintaining things. So I've got a picture of this little growing, I think this might be a bean, actually, this little seed growing. So growth is part of development. Gaining the ability to speak a language, maintaining that ability. So maintaining whatever ability I had to speak French, which I didn't after high school. And so I lost. That was a decline. I did not regulate that loss very well. I pretty much lost that ability to speak French. So growth, maintenance, and loss is all part of development. So with that, development is that individual person over the course of time through their lifespan changing due to their biology, their culture that they're in, the context that they're in. So development in many ways is all of these things. Development is all the things. So we, as developmental psychologists, we kind of try to bite off a big chunk of human psychology. And we need to work multidisciplinarily. We need to work with social psychologists and neuroscientists and medical practitioners, doctors, nurses, social workers, teachers, people who are trying to implement change, do studies on that change, try to understand what they've observed about change over time. So it's kind of a big field, and it's started off really focusing on children and the changes children made, trying to see how children grow into adults. Over time, there was recognition that, well, the years after a child was 5-year-old are important too. And so measuring those changes, then realizing that, oh, adolescence is very different than adulthood. So we need to look at that. And then there's early adulthood and middle adulthood and late adulthood. And I'd be very surprised if there's not a new category soon. More categories within adulthood as more and more research is being done further on or in more depth in adulthood. We talked about research methods specifically earlier today on experiments when I talked about my mindfulness experiment. We've mentioned some of these types of research designs, these methods used for developmental work, but let's dive into them in more specificity right now. So we're going to focus on two: longitudinal research and cross-sectional research. Both of these are considered developmental research designs because they're really well suited to looking at change over time. And if you look back at that model, that's what development is looking at, is change over time. So a cross-sectional study would be taking people of different ages and measuring them at a single point in time. So let's say you wanted to know how attention and speed of solving problems changes over time. So today you could go out and you could measure a group who is 55 years old, a group that was 60 years old, and a group that was 65. So different people in different places. Maybe you have all the 55-year-olds come to one office room, the others or different labs, but you measure them all today. So in one day you get a measure of what were the examples that I gave? Processing speed and solving problems. So you give them measures to assess their processing speed and how well and how quickly they can solve problems. And so you see, well, does the 55-year-old, do they do it better or faster than the 60-year-old? Does the 60-year-old do it better or faster than the 65-year-old? Or does the 65-year-old do it better and faster than the others? So it gives you a sense of, does this processing speed and problem solving ability, does that change over the course of those years? You could do that with 5-year-olds, 7-year-olds, and 10-year-olds as well. You could look at that change over time. So cross-sectional is you take a section of people, cross sections of people, so of different ages measured on essentially one day or at one single point in time. Longitudinal designs are different in, well, okay, cross-sectional designs do allow you to infer things about development. So if you see that the 65-year-old is the best or the fastest at solving problems, the 60-year-old's in the middle, and the 55-year-old is the slowest, maybe you would make the assumption that you could infer that as you get closer to 65, your processing speed is increasing. So this is nice and convenient to do a research study like this because you only have to measure today, this one point in time. So it's cheaper, it's quicker, you get your results fast, you can publish those results. Longitudinal designs are a little different and in a lot of ways are better, but do have some weaknesses logistically. So longitudinal designs, you will follow the same group of people over time. And so that's really great because then you can watch that change happening over time. So you could watch children in infancy all the way up through adulthood until the time that they die. So you can do a longitudinal study following the same 600 people through their entire life. So that would be a really good way to get some assessments of a lot of different things. How does their physical change happen over time? What kind of cognitive changes happen over time? So an example is similar to our last one. You could take the 55-year-olds, measure their cognitive speed and speed of solving problems, and then you could follow them again 5 years from now when they're 60, and you can measure that again. And then you can go and measure them again 5 years later and see from that group of, let's say, 200 people that are 55 years old, you measured their cognitive speed, their processing speed, then you measure them again when they're 60, and then again when they're 65, you'd get a lot better sense of their change over time because you can actually see that it's these people changing because you had their measure before, now you have their measure after. Versus if it's a group of people who are, if it's cross-sectional, you've got the 55-year-olds, the 60-year-olds, and the 65-year-olds, they might have been affected by different things. Maybe the 65-year-olds, all of them went through a war and their school was different because of wartime, and so they learned techniques that made them better at solving problems. So that would be called a history effect. But if you have the 55-year-olds and you follow them the whole time, the history effects should be gone because they should all be having the same history effects. So again, it still might not be because they're changing over time. It still might be that history effect, but it's a little clearer that way. So here is a graph from a longitudinal study looking at cognitive abilities. So this study looked at inductive reasoning, spatial orientation, perceptual speed, numeric ability, and verbal memory. So a lot of cognitive processes and cognitive abilities from the time people were 25 all the way till they were 88. And you can see a lot of these cognitive processes stay really consistent for a long time. It's only until we get essentially into the 80s that we see pretty significant declines of these. And further studies have seen that people can, especially if they see a start in any of these declines, if they work on those with, say, there's a lot of apps now that can help you with a lot of cognitive abilities. So numeric ability, verbal ability, perceptual speed, spatial orientation. So if you work on those specifically, you can maintain those cognitive abilities and even increase them. So these are just people living just their day-to-day lives, not doing specific training for these things. So this is on average what will happen. But if you do training, you can maintain this, so these cognitive abilities stay sharp through all of life, or even increase at the end of life. So pretty inspiring thing and good, because people before this kind of study, they thought that we were losing a lot of cognitive ability a lot earlier in life, in 50s or 60s, when really it's not until the middle to late 80s that we really dramatically started losing any of that cognitive ability. And then we can change that. We can make sure that we maintain or even increase that cognitive ability. And so that's how you would do a longitudinal study. This would be I forget how many people were in this study. It was a pretty large number though. So I think it was 600 or 800 or something like that, or they started with 800, then ended up with 600. So that is one weakness of longitudinal studies, is you have to follow those same people. So, and that can be hard. People move, people decide they don't want to be part of the study anymore. Yeah, so it's hard, but it is more rigorous. It's easier to find good. You can actually see some causal data from longitudinal studies. So another way that you can do a study on development is the sequential method. So we have cross-sectional, where you take people at different ages at one point in time. We've got longitudinal, where you follow one group over a long time. So long, longitudinal, follow them over a long time. Sequential puts those together. So you start with a group of 55-year-olds and 65. So you do a cross-sectional study today of 55 and 65-year-olds. Then 5 years from now, you follow those two groups. So now you have 55-year-olds and 60-year-olds and 65-year-olds and 70-year-olds that you can compare to each other. Then you follow them another 5 years later. So now you have a data set that spans from 55 all the way to 75. But you only had to do, what would that be then? 10 years? So 5 years here, 5 years, yeah, so 10 years. So you measure them once, you get some cross-sectional data, you can write a paper on that now, follow them up 5 years later, and then 5 years after that, and you can get some longitudinal papers too. So a longitudinal study at minimum needs 3 time points. Otherwise, it's not actually considered a longitudinal study. A sequential study is combining the cross-sectional and the longitudinal. So it doesn't fix all the problems of either, but it gives you some of the benefits of both too. So it's a nice method. All right, so cross-sectional, multiple different age groups at one point in time. Longitudinal, same group of people, hopefully a large group of people over a long period of time. Sequential, put both those together. All right, so in our book, it essentially breaks things into socio-emotional development, cognitive development, and biological development. With that being said, all of these things actually are happening at the same time. So it's easier for us as humans to kind of think about them in their little boxes, like what are the biological changes that are happening? How quickly is a child growing? How quickly is an adolescent growing? How is the brain growing? But how is the brain growing is really related to cognitive processes too, and also socio-emotional processes. As an example, we've talked about the myelination of the brain before. In adolescence, the emotion centers of the brain are finishing their myelination early on in adolescence, like 13, 14, they should be done by about that time. So what that means is these 14, 15, 16-year-olds, they are feeling more emotions and stronger emotions that they have ever felt in their entire life. So that's the biology affecting their socio-emotional processes. It tends to lead to more risk-taking behavior because they're feeling more intense pleasure than they ever have. They might be trying out uses of drugs. They might be getting into sexual relationships because they're having all these more and stronger emotions. Additionally, their prefrontal cortex, a thing that's focused on goals, planning, and inhibiting some of these maybe, and thinking off into the future, that's not fully myelinated yet. So you'll see a lot more risk-taking behavior when that biological process leads to these socio-emotional processes, because those cognitive processes of reducing your risk-taking behavior are not in place yet because of biological processes. So all of these are happening at the same time. The biology cannot actually be separated from the cognitive. The biology can't be separated from the socio-emotional. Socio-emotional also can't be separated from the cognitive. But in our books, we kind of compartmentalize them to talk about how socio-emotional development happens over time through the lifespan. So it can be a useful way to learn them, but also remember all the other pieces are happening at the same time too. All right, so biological processes, things like physical changes in your body, hormone changes, nutrition, motor skills, development of the brain. Cognitive processes are thinking, memory, problem solving, intelligence, perception. Socio-emotional are emotions and emotional development. So anger, empathy, personality development, relationships, social situations, social context, those all fall into socio-emotional development. So we'll talk about these. We won't hit on each and every one of them at every stage of life because we just don't have enough time for that, but we'll hit on a couple of them at a couple specific phases of life. So we kind of separate them, but remember they're happening at the same time. So these are the periods of development that we've kind of agreed on separating. So prenatal is the least controversial one. Time does it cover? It covers from conception to birth. So that's the prenatal period. That's pretty easy. And the ones in early childhood are pretty well agreed on too. So infancy is birth to about 24 months. Early childhood is from about 2 to 5 years old. Middle and late childhood goes from about 6 to 11 years old. Adolescence, depending on who you ask, starts at about age 10 to about age 13. So somewhere in there is when adolescence starts, and then it goes till about 18 and 19. So that is considered adolescence. Other researchers might even say adolescence ends closer to 17, and early adulthood extends all the way down, or that young adulthood might be. So there's some disagreement on where these cutoffs are, but these are what your book says. This is what the slides say. This is what your exam will say. If it's asking about something in adolescence, this is the time span it's talking about. Early adulthood is generally the 20s to 30s. Middle adulthood is about 35 to 65. And you can see that's a lot of years there. Middle adulthood, 35 to 65. That is many, many years. And then late adulthood, mid 60s to death. That's a lot of years too. If you have someone living till mid 90s, so that's quite a number of years. So we'll talk about a couple specific examples of why I think in the future we'll probably have some more divisions here, some more clear divisions of different portions of adolescence, some different portions of early adulthood, some different segments in middle adulthood as well as late adulthood. For example, the mid to late 80s and on, I think that might end up being the new late adulthood, but this is what we're at now. Emerging adulthood is another slightly controversial period of development. It's from about the age of 18 to 25. And so this is really characterized by continued identity exploration. So years ago, it was thought that identity was pretty well figured out in adolescence, but then we saw this evidence of emerging adults who are still looking for their identity, maybe coming home with a PhD but still living with their parents kind of thing. Instability, so instability in their economic life. So they don't have a home outside, they're still living with roommates or something like that. Still a lot of focus on the self and feeling in between adolescence and adulthood. So this is seen a lot more in US, Australia, and many European countries, especially when going to college full time and getting degrees is emphasized. So in those cultures, this is seen. In other cultures in the world, this emerging adulthood doesn't seem to exist. So the argument is, well, should we consider this its own phase because it's really exclusive to a lot of these Western cultures, or should we consider it a phase of development? I'm of the idea that we can just talk about emerging adulthood in the context of early adulthood, because some of these things like identity exploration, even that still exists cross-culturally, like some of these aspects, and you can call it as something in emerging adulthood, or you could talk about it in relation to early adulthood. So some developmental journals that I publish to will not let you mention emerging adulthood. Like their editors really, they don't like emerging adulthood. There's some of the ones arguing that it doesn't really exist or it shouldn't exist because it's not worldwide. So for those, I will definitely always publish it as early adulthood or young adulthood, versus other journals would be like, hey, we want research on emerging adulthood. So I might just change those young adulthood words to emerging adulthood. So just to give you a sense of what the field is doing with these ideas right now. So some of the things that we'll talk about in relation to development are nature and nurture, stability and change, continuity and discontinuity, and early versus later experience. So you might even put a versus in those versus the and. So nature versus nurture, or stability versus change. So this is probably one that you're familiar with hearing, is nature and nurture. So nature is in relation to biology, genetics, things like that. Nurture is dependent on the environment, so how a person was raised, things like that. So let's vote. Just put in the chat, what do you think? Is development more based on nature, or is development more based on nurture? So just put it up in the chat. Which one do you think it is, nature or nurture? All right, I see 5 responses right now. I see 2 votes for both, dependent on the age period. So we've got both. We've got some nurtures. We've got nature. It depends on age. So maybe 40, 60, and 60 going to nature. So some disagreement here. Some people think both. Some people say nature. Some people say nurture. So, and some people say it depends on the age period. So I'd say probably that it depends on the age period is, and not just the age period, but specifically what you're talking about as well. But probably the most accurate short answer is both. So good job, students. You figured out my trick. I gave you 2 options and you took not those 2 options. You said both. So good job. Because yes, most everything in development is some combination of both. So some combination of biology, cognitive, and socio-emotional development. So some combination of your genes and your biology, as well as how you're raised and how you're interacting with your environment. So it depends on the level it is at what age. The language example we gave earlier. So you develop language early on, and a lot of that seems to be driven by biology and nature. So we have a natural capacity to learn language early on, but we can still learn languages later on in life. So maybe early on in life, it's a little easier because of that nature, and then later on, depending on how you're nurtured, you still can develop that ability. As an example of something that is a little dependent on both in the first place too. So stability and change, same kind of thing. Stability is that a person's personality or temperament, who they are, remains really stable throughout life. And change is that your personality or temperament, like who you are, can change through life. So same with this, it's very both. Some things about a person will tend to remain stable throughout life, while others have varying levels of change. Again, it kind of depends on what you're talking about specifically. Continuity and discontinuity. Continuity is the idea that change is constant and cumulative. So you would see that as like something growing like really consistently, not having really big jumps ever. Discontinuity is changing in separate distinct stages. So rather than growing kind of continuously, there's some really big jumps. So both exist in development, but most aspects of development are continuous. Most happen like slowly over time, but there are examples of things that are very discontinuous. As an example, growth spurts. So physical growth spurts. So for a infant under the age of 1, generally they don't actually grow physically anyway, continuously. So their physical height, like length growing, that usually happens discontinuously. So you might have an infant go for 2 or even 3 weeks with no vertical growth, like their bones stretching and lengthening. And then over the course of 24 or 48 hours, they can grow. The largest reported is almost an inch in a day. So pretty dramatic. Growth spurts can be really dramatic. So that's one example of something that is discontinuous. But many other things like our myelination in our neurons, it's kind of both continuous and discontinuous. When it's happening, it's kind of a slow, steady process. But then adolescence is a time it kind of increases for a time. And then early adulthood, it kind of speeds up as well. So, but it is happening all the way from basically the time our neurons are set in place around age 2. So a little bit of continuity and discontinuity there. So learning to read is often seen as a really continuous process. Like you make sounds, you're hearing sounds, you start to recognize shapes, you start to recognize letters, start to put letters together and the sounds together, and be able to read a whole page. And my daughter started off reading like 1-word or 2-word sentences, and now she can read like an entire paragraph, right? So that was a pretty continuous change. This example is really interesting. So the ability to think abstractly is really dependent on biology. So when the neurological development allows it, essentially, is when the neurons get connected up in such a way that we can think abstractly, then it happens. And that doesn't seem to happen until close to around age 7. So at about that time, we can finally start to think abstractly. But before that, and it's almost as if it's a day-to-day change, that the neurons are not fully connected up and then they're connected up. So it's like day-to-day, it's a dramatic change. Yeah. But again, most development is pretty continuous, slow, steady change, but there's aspects of discontinuity to it. So early experience is asking things like, is the first 5 years of life more important, or later experience? Are the later experiences in our adolescence or early adulthood, are they more important to our lifelong development? And so again, it really depends on the topic. So if we're talking about language development, childhood is easier, but attachment. So having a secure attachment, your attachment style can change in your second decade of life. And that can even alleviate some of the problems that came by not having a secure attachment in your first decade. So generally people keep their same attachment style, whether they're securely or insecurely attached. And usually that's down to your caregiver, your primary caregivers, and if you're securely attached to them. But with that being said, people tend to find and end up with partners that are a similar attachment style to them. So people who are insecurely attached, tend to find romantic partners who they are insecurely attached to, and that partner is insecurely attached to them. But if a person with an insecure attachment is partnered up with a person with a secure attachment, the person who originally had the insecure attachment can learn what it's like to have a secure attachment and then expect that for the rest of their life and have some of the positive benefits now of having secure attachments. So early versus later experience depends on what you're talking about. So many of these things that we're talking about are related to the idea of developmental cascades. So like a cascading waterfall, any given water molecule might start here and then run down this path and then run down this side of this path, but then this side of this path. Development happens in a similar way. Any individual person might start towards, let's say the left side of this is negative versus the right side is positive. So the left side of this towards maybe more negative outcomes. So maybe the child has some sort of developmental disability as well as is in poverty and in a culture that is currently war-torn. But then because of other aspects of their context, they have some protective factors. And so they are more over here. And then based on some of their choices, they end up being more over here. And they end up having very positive life, even though they might have started off in a way that seemed like they were kind of doomed to a lot of hardships. Same with someone who maybe is born with a lot of privilege. They can encounter situations or have troubles that lead them developmentally towards maybe some more negative outcomes. So both based on the context that they're in, their culture and society, and the situations that they're in, as well as their own biology or health or the choices that they make themselves. So development can happen in these kind of cascades. It's continuously changing. People have plasticity. Even if we are dealt a bad hand, it's possible in many ways to improve a lot of aspects of ourselves. So that's why I also have this Plinko board here. It's another visual example. Basically, you drop a ball here and it kind of bounces. And so you want it to land on like a high value place. And that's kind of what development is. As developmental scientists, we want people to land in the end on like a life with well-being and purpose, and that they are happy of and proud of, and that they have a lot of well-being. I think I already said that, but it's kind of an all-encompassing term. And so we want that for people. And so we try to help encourage them. We encourage protective factors, good parenting, good schooling, good institutions to help encourage and get people that way. Yeah. So with that being said, that's a good intro to some of the big concepts that are important in development. And then, well, we are actually out of time. I was like, this is a good place to stop, but we actually do have to stop. It's the end of class. So we'll talk and start at the prenatal period of development. And then next class period, we'll talk briefly about a lot of different periods of development and a couple key things I want you to know about development, so that you know a little bit about lifespan development. But hopefully you have some ideas in your head of what's important about how we look at development and study things. So definitely try to get in touch with the groups that you might want to get involved with for your projects. So contact them. If you saw anybody who was interested in being on your project, please do contact them as well, if you're already part of those teams, and we'll get to work on that. Send me emails as well if you're confused about things that we've talked about today or about the group project. And thanks for being here today, and have a good rest of your evening.